Characterization of mechanical properties on Tamarind Shell, TS, powder and wood apple shell, was, powder reinforced with epoxy resin and hardener. Abstract in the present work, variation of tensile test, compression test, bending test, and impact test of the Tamarind Shell, TS, and wood apple shell, was, particulate composites was studied. From experimental results, it is found that composites prepared with 25% of WAS and 5% TS powder reinforced epoxy composites exhibited better tensile, compression and flexural properties as compared to 0% plus 30%, 5% plus 25%, 10% plus 20% and 15% plus 15% combinations. For impact studies, all samples have exhibited the same amount of energy absorbed for all combinations. This study reveals that, drop in the mechanical properties for the 30% was plus 0% TS composites and slight increment in the mechanical properties for increase in the TS percentage with the WAS. Keywords: Tamarind shell powder, wood apple shell powder, hardener, resin, hardener, impact test. Introduction. A composite material can be defined as a combination of two or more materials that results in better properties than those of the individual components used alone. In contrast to metallic alloys, each material retains its separate chemical, physical and mechanical properties. The two constituents are reinforcement and a matrix. The main advantages of composite materials are their high strength and stiffness, combined with low density, when compared with bulk materials, allowing for a weight reduction in the finished part. The reinforcing phase provides the strength and stiffness. In most cases, the reinforcement is harder, stronger, and stiffer than the matrix. The reinforcement is usually a fiber or a particulate. Particulate composites have dimensions that are approximately equal in all directions. They may be spherical, platelets or any other regular or irregular geometry. Particulate composites tend to be much weaker and less stiff than continuous fiber composites, but they are usually much less expensive. Particulate reinforced composites usually contain less reinforcement due to processing difficulties and brittleness. The continuous phase is the matrix, which is a polymer, metal, or ceramic. Polymers have low strength and stiffness, metals have intermediate strength and stiffness but high ductility, and ceramics have high strength and stiffness but are brittle. The matrix performs several critical functions, including maintaining the fibers in the proper orientation and spacing and protecting them from abrasion and the environment. In polymer and metal matrix composites that form a strong bond between the fiber and the matrix transmits loads from the matrix to the fibers through shear loading at the interface. Materials and methodology. The flow chart shows the experimental work of the present work. Wood apple shell powder. The wood apple shell was dried in outside and granulated into powder utilizing a pummeling machine. The powder was sieved as per BS 1377:1998 standard. The compound investigation of the wood apple shell was finished with absorption spectrometer, AAS, PEC in Rudder 2006 model. The pelletized polyethylene waste was sun-dried and destroyed in a plastic smasher machine. The molecule size utilized was 280 AAM. Tamarind shell powder. Tamarind is one of the very developed trees in India. India is one of the most astounding cultivators of tamarind on the planet. Tamarind comprises of three sections: tamarind organic product mash, which is palatable, hard green natural product mash, and tamarind seed. Tamarind organic product test powder, commonly known as tamarind shell powder. Matrix system. Epoxy L12 is a fluid, unmodified epoxy sap of medium thickness which can be utilized with different hardeners for making glass fiber fortified composites. Hardener K6 is a low consistency room temperature restoring fluid hardener. It is normally utilized for hand layup applications. Being fairly responsive, it gives a short pot life and fast fix at ordinary encompassing temperatures. Size of particulate composites. A form of size 280 mm x 150 mm x 6 mm was set up of hardened steel for getting ready plate tests. Form comprises of a base plate, outline that could be destroyed to encourage simple evacuation of throwing after the restoring. Every one of the surfaces of the form was covered with wax. All the internal surfaces of shape, interacting with surfaces of composite to be cast are spread with uniform covering of wax so as to encourage the arrival of the cast piece. Conculsions. The variation of tensile, compression, bending and impact properties of the tamarind shell and wood apple shell particulate composites was studied. From experimental results, it is found that, composites prepared with 25% of WAS and 5% TS powder reinforce epoxy composites exhibited better tensile, compression and flexural properties as compared to 30% WAS plus 0% TS, 20% WAS plus 10% TS and 15% WAS plus 15% TS combinations. For impact studies, all samples have exhibited the same amount of energy absorption, 2 joules, for all combinations. This study reveals that, drop in the mechanical properties for the 30% WAS plus 0% TS composites and slight increment in the mechanical properties for increase in the TS percentage with the WAS.